Conference, your source for GraalVM knowledge.
Obviously, it's not a workshop to become an expert in Docker or become an expert in Kubernetes. It's impossible in 2 hours. Okay? But the idea is to give you all the tools you need to have a basic knowledge of that, and then go ahead and go deeper in the part you really are interested in. I know you are quite tired after 2 workshops, right? Maybe. I am at this. It was very interesting, both of them, but it's a lot of information. So I will try to do it as much fun as possible and explain everything clear. But if you have any question, please just raise your hand, share what problems you are having, and we will try to solve it together. Okay. So what we are going to do today is we're going to start explaining and using Docker. How many of you already work with Docker? Okay, not too much. Yeah, that's perfect. That's perfect. Okay. We're going to explain it from scratch. But as I say, don't pretend you are not going to leave the workshop being experts in Docker, but at least understanding why it's important and learning how to use the basic things. Okay. For the people who already know Docker, that part is going to be a bit boring. Sorry, okay? But I need to cover that, explain Kubernetes later. So we are going to start with Docker. We are going to explain some advanced things regarding the problems we have running Java applications in Docker. And then we are going to start with Kubernetes. How many of you are using Kubernetes? You are in the perfect person to solve that.
Versus just the last so much time.
Yeah, that's perfect. So once we know how to use Docker, we are going to do the same with Kubernetes. We are going to work with a local installation in our virtual machine, and we are going to learn how to deploy things in Kubernetes, how to start to work with it, and the basic concepts. Again, Kubernetes is a huge project, a lot of concepts. So I'm going to explain the basic things to understand why it's important, why you don't need it, and how to deploy things. But there are a lot of other things in the Kubernetes ecosystem you will need to learn in some point. Okay? So this is just introductory to Kubernetes, but enough to continue and grow. For both things, we are going to use a Micronaut application. There are several reasons. The first one is because I think Micronaut is quite good for this conference. Because Micronaut is a framework which pretends to be cloud native and solve some of the problems we are going to describe here today. So if you want to run Java applications in Docker and Kubernetes, Micronaut is going to solve some of the problems, and it's very promising. I am not going to cover too much about Micronaut, only the parts I have interest on, because there are other workshops and talks specific for Micronaut. This is a very good example to start to work with Docker. And finally, we are going to use, to create the Docker image, we are going to use GraalVM. Someone is using GraalVM? No. Okay. GraalVM is something very new. A lot of people are speaking about it, so I'm going to cover it. You are going to have the opportunity to use it, to install it in your laptop, and see the difference with the OpenGDK. So, why a virtual machine? Okay, well, as far as I know, we have 3 options to work with Kubernetes. Okay? The first one is go to the cloud. Kubernetes is mainly designed to be deployed in a cloud provider like Google or Amazon or something like that. So that makes a lot of sense. You don't host your own Kubernetes infrastructure, you just use one provided by a cloud provider. For a workshop, it has some problems. The first one, it requires internet connection, okay? And you need probably to load Docker images and things which can be a bit heavy, so it's not a good idea. I know some people have been doing it quite well, but it's problematic. and it's expensive. Okay? Even some people working with Kubernetes, which doesn't have too much support from their companies, they avoid this, okay? Because you start to launch a lot of containers and things, you have to remember to delete them and so on, and can be quite costly. Okay? If you work in Google, the other option is to use Minikube. Minikube it's a tool you can install in your laptop, and it's going to create a virtual machine, Virtualbox machine, with Kubernetes. It works quite well. Okay, so probably if you are going to use Kubernetes a lot, take a look to Minikube. I personally don't like it because I started to use Kubernetes some years ago. It was just not too stable yet, so I have some problems. I'm trying to. I was just fixing Minikube problems instead to focus on Kubernetes things. But I know it's a lot better now, so it can be a good option. For a workshop, it's a problem because you are using Mac, Linux, Windows, and the setup of Minikube is a bit different from one operating system to another. And finally, you use your own virtual machine. Okay? For me, I like this way. It's very flexible. You learn how really Kubernetes works. Maybe the problem is it's quite complex. The setup of Kubernetes is not easy. It's not a straightforward. It has a lot of gotchas. So if you want to really understand how Kubernetes works, that's a good way. If you don't care too much and you just want to use it as a developer, focusing on the APIs, that's not a good option. Okay? So let's start with creating the Virtualbox image. So basically, we're going to open Virtualbox. Well, you have all the instructions in the presentation. So let's create a new image. It should work with 2 gigas of memory. I usually agree. So we say, okay, but it should work, and don't add a new virtual disk. And we create. Okay, all of you have the virtual machine already in the computer? No. Okay, so who has the USB sticks? Here. There are 3 more. You have one?
Yes, but I'm using it.
Okay, okay, no problem. So let's. Oh, sorry. I use Virtualbox 5, I think, this computer. I know some people use it with Virtualbox 6 and they don't have usually problems. Okay, if you have, just downgrade to next version. It should work. And I'm just going to give you some minutes to finish distribution of the virtual machine. Te contaba la cosa que voy a enviarte para sí, sí, no, no, con Java 8 digo para hacer un ejercicio con Java 8.
Dénoncer directement de l'application. J'ai pas dit que les applications, ça doit être
It's impossible to do it. I mean, I just repeat this again. Go to this website. Here you have the code and the link to the presentation. So you can copy the commands and see all the instructions. Okay. Also in the agenda in the website, each agenda, you can have also the link to this website. So it's easier for you. Okay, how many of you don't have the virtual machine yet? Just one? Okay. Let's do something different. I'm going to introduce first Docker and some of the things in Docker, so you can finish the copy the machine, and then we come back to the Virtualbox environment. So Docker. Okay. Some people explain Docker as virtual visualization technology, so it's like a virtual machine, but you are sharing part of the libraries. Part of the runtime with the host machine. Okay, that's more or less correct. I don't like too much that approach. Okay? For me, Docker is just a standard way to package applications. Okay, it's just something like that. You can package an application. It doesn't matter if it's a Java application, a Groovy application, a JavaScript application, or a C application. All of them are packaged in the same way. So you can share them in the same way. Okay? So the most important thing for me about Docker is not the technology itself, it's about the standardization. Okay? It's a good way to manage applications from different platforms in the same way. Okay? So that allows us things like rapid provisioning, rapid application deployment, and make things a lot more agile. The way to achieve that is because, well, it's not exactly the way. The other important thing about Docker is automation. Okay, the way you create an image of Docker, it's totally automated. Okay, you have like a DSL or a YAML file, a file where you describe all the steps, okay, to build your image, okay, and you launch the build command and it's built, but you have a file where you can control all the changes, what you are doing, how you are doing it in different layers, and so on. Okay, so that gives us a lot of flexibility, and you can use it as documentation here. So you can extend it, so you can use an image from another company and add your new layers with your custom configuration. So it's very, very agile to use it that way. Okay, it helps a lot. So we have all these two things are very important. The third one is isolation. Okay? Docker allows us to launch applications in a server, specifying what CPU and what memory we can allow that specific application to use. Okay, and it can run separately of the other applications running in the server. So now we have bigger servers, we have the cloud and so on, and we can use Docker to launch more than one application in one server and making sure they are going to interfere with each other. But that has some problems, okay? Specifically with Java. Java is not designed to use like that. It's exactly the opposite here. Java, the Java virtual machine, the Java platform has been designed to maximize the throughput, and for that, Java tries to use as much resources they have in the machine. And it makes a lot of sense, and it gives us a lot of advantages. For example, we don't need to do too much tuning in Java, because Java is able itself to auto-tuning and to choose what memory needs, what CPU needs, and how to do all the dimensioning of threads and so on by default. There's a lot of logic inside the Java virtual machine to do all those things. Okay? So we have Java and we have Docker, which is exactly the opposite philosophy. And for example, in Docker, when a container is consuming more memory than the memory which is allowed to consume, Docker, what it's going to do? It's going to kill it. Okay? So if you are running a Java application in Docker and it's consuming a lot of memory for whatever reason, okay, Docker, what it's going to do? It's going to kill it. Okay? And that's a big problem. You have something in production and it's a problem. So you would say, okay, no problem, I'm going to limit the memory of the Java virtual machine. Okay? But it's not so easy, because when we limit the memory, we typically limit the heap memory, but the Java virtual machine is using a lot more memory. Memory for garbage collection, for threads, for internal caches, and things like that. So it's not so easy to know how much memory is going to consume the Java virtual machine. And now we need it. There are more problems. CPU. When you run a Java virtual machine, a Java application in Docker, typically you limit the amount of CPU it can use. Okay? But the Java virtual machine is going to see how many processors are in the server, and it's going to do a lot of tuning based on that. Things like fork join, or how many garbage collection threads are going to use, and so on and so forth. It's based on the number of processors. Okay? But now you're running Java in a server, which may have a lot of processors, of course, but it really doesn't have access to them. So the dimensioning which Java is doing is wrong, and it's going to generate problems, or at least inefficiencies in production. Okay? Do you understand that part? Because it's quite important. Yeah. Yeah, let me quote an example. You have a server with 64 processors, okay? Processors, yes. But when you launch the Docker image, you limit to 2 of them. Okay, that Java virtual machine, that Docker image, you're going to ask for the number of processors available, and it's going to say, okay, I have 64. So I can launch 64 threads in a fork join tool. Okay, but in reality, it only has 2. So it's launching a lot of processors, consuming a lot of memory, and fighting for resources in the machine. Okay, but it's not more problems with Docker and Java. If you launch, if you create a Docker image, a default Docker image using the full GDP, is around 500 megabytes at least. Okay, that's a lot. If you compare with other runtimes, that's Go, or Node.js, the images are a lot smaller. So when people start to use Java with Docker, say, okay, this is a problem, especially because if you are going to use Kubernetes, you are going to move images and instances of images from one network to another one, from one server to another, you are going to load them from the registry, so it's a lot of bandwidth consuming. And if you are running it in a cloud environment, it's going to cost you more. Okay. So that's another problem. Java 9, how many of you are using Java 8? Almost. Java 9? Almost not. More than Java 9? It's, in every conference I ask this, it's always the same. Okay. Java 9 was polemic when it was launched, but has a model system which is quite good for this. Okay, it allows us to generate a custom Java runtime only with the parts of Java we need to run our application. Most of the applications we don't need Corba, we don't need JavaFX. There are a lot of things we don't need. Okay, so with Java 9 you can you can create a custom runtime to create your own Java runtime, which is going to be smaller. Okay, that doesn't mean you need to use modules and to split your application in modules. Even if you are not using that, you can use a custom Java. There is also Alpine Linux. Alpine Linux is a very small Linux distribution, which is only 4 megabytes. When you create a Docker image, you have to specify what is the distribution, the initial distribution you are using. So you can run a Docker image in Ubuntu, but it can be created from a Red Hat image. Alpine Linux is a lot smaller, so many people is using it just to save space and to have a smaller Docker image. The thing with Alpine is it uses generative C, it uses MuseD, it's a different C compiler, and is not supported out of the box by Java, but there is an Oracle project or an OpenGDK project or a project Portola specifically doing this thing, making Java work out of the box in Alpine Linux. It's not experimental yet, but it's working quite well. Okay, so before to continue with Docker, let's start with the Virtualbox thing. Everybody have the virtual machine now, right? So let's create the virtual machine. Once we have it, we go to settings, and in storage we are going to add the disk we have in the copy from the USB. Okay. And then in network, we are going to use 2 adapters. Okay, one is going to be internal for Kubernetes, and another one is for us to access the virtual machine and to have internet access if we want. So for adapter 1, we are going to use NAT network. Okay. Before to do it, let me explain something. And for adapter 2, we are going to use. You have 2 options here: bridge adapter. If you have Wi-Fi access, you are going to give internet access to the virtual machines. That's perfect. Some people have problems with this because software protection in the key, in the laptop, things like that. In your case, you can use also a host-only adapter. Probably you are not going to have internet, but you shouldn't need it. Okay. Which is important here. It's for the adapter 1 for the NAT network. You may need to create the network first. Okay, so in File, you go to Network Operation Manager, host network manager, sorry. And here you can create a new network, okay? Just you can here create a new network, okay? If you don't have it, make sure you enable the DHCP server. That's one of the things. Another one is in preferences. You can go to network and create a NAT network. And this NAT network should have this network, okay? 10.0.2.0, okay? And support DHCP. Okay, so this is the most important thing, okay? Use this network. I know. This is the most complex part of the work. Everybody is saying the same. Once you have the virtual machine running, no problem. Docker and Kubernetes is the easier part. Okay. So I'm going to spend some time just making sure everybody first add the disk. Okay, that's easy. Second one, you need to create this network. Okay, so that's very important. So go to File, Preferences. Okay. If you don't have a network, create one. Okay. If you have one, just create another one. That's perfectly fine. And make sure you are going to use this network. Okay. And support the HTTP. Once you have that, this is optional if you don't want to use Greach network by default. Forget it, use Greach network. And now configure the network in your virtual machine. So go to settings, adapter 1, select NAT network. The NAT network will be already created. Okay. And for adapter 2, you can use Greach adapter, or if you prefer, if you have any problem, host only allowed. Is it a bit more clear now? Just let I will help personally. When you have that, start the machine. It should work, okay? So, someone has problems with that or is lost, please raise your hand. No?
I think I have another version of Virtualbox. So we have adapter 1, adapter 2.
Yeah, that's perfect. Let me check adapter 1, NAT, change to NAT network. RedNAT, este es español.
Sí.
Nombre. Vale, la tienes que crear antes, entonces cierra ahí un segundo. Archivo. Preferencias. Red. Créala ahí. Déjame ver los. El amarillo. 10.02.24 soporta TCP. Perfecto. Aceptar, aceptar, y ahora en settings otra vez, la pones en el adaptador 1 y en el adaptador 2 yo pondría Greach, ¿vale? Si tienes algún problema o lo que sea, pues miramos, con el antivirus a veces alguna cosa.
Muchas gracias.
You may use Greach adapter.
You have to create the red NAT network before
it's asking for the password, you are in the perfect position. Any problem more?
No, global menu. I don't know if I can change
From network preferences, wonderful network.
Okay, I'm going to go ahead a bit more, and then I will show you again. Someone is not. So, for the login, you have it in the presentation. Guess. Okay, so what I recommend here is just
you have to select it from the
see your IP. We have config more. You have here command, okay, presentation. And you are going to see it has several interfaces. The 8 interface is important. It's going to have an IP, okay, and you can from your laptop access that IP. Okay, so what I recommend you is access by SSH to the virtual machine. Okay, so also a recap. Log into the machine, see the IP with ifconfig. Remember, you have the command here. Okay. See what is the IP of the S8 interface, and using it and to log in using PuTTY or command line, whatever you prefer, to your to the virtual machine. Yes. So, problems. Maybe don't be afraid, I know that's the complex part. Okay, after that we go a lot faster.
Genau, das ist Dokument. Okay.
A lo mejor prueban ejecutar el VirtualBox como administrador, a ver si va a ser algún problema por copiar la nuestra ubicación, a lo mejor un tema de
Jetzt gehst du daher, probierst das noch ein bisschen zu sein, du musst es noch mal so viel. Das gibt es nicht mehr.
Someone more with problems? Okay, let's do this. Seguro que con control tenéis un trabajo de todo de una asociación para hacerlo más grande, pero si entráis por necesidad se llama falso. Okay, more problems? Okay, let me. If you need to change the layout in the presentation, you already have the command, okay? So US or whatever language. By default, I think it's in Spanish. You shouldn't need to change the IP, but you can check it's working, and you can type these two commands, Docker image, Docker PS, just to see if Docker is working, okay? But we'll explain them later. Let me check the problem is that this is H.
Anton scharf ist, rechtes auch noch? Nein, ja, rechtes auch. Das ist rechts, ja. Und dann falsches Wort. Der rechte ist es. Also, wir haben 10, 15. Sind wir zu 15. Gut. Und der 8. ist...
Ist das also der
Broken File. Fuck. Why? Broken File. Password. No, you have to So, jetzt bin ich wieder draußen. Talk to me, talk to me. Talk to me. Come on, talk to me.
Any problem more? How many of you are connected to the machine by SSH?
Wrong interface.
Okay. What I'm going to do now is advance a bit more. Try to give some time. Let me finish to explain some things about Docker. I was explaining before the problems we have with Java and Docker, right? Memory, CPU, and the size of the images. Now you have to see how to solve them. You know how Oracle, Red Hat, and all the people developing Java solve them. So there are many projects ongoing or in the last Java 10, Java 11 version to improve how Java is running in Docker. Okay. The first one is for the problem with the memory. Now you can run what is Java, the GDK doing, it's asking to Docker, to the operating system, what is the limit, and taking that limit in account, okay, to avoid to be killed, okay. But it's very conservative. So basically, what Java is doing is setting the heap size of your application just to 1/4 of the physical memory available. Okay, so if you have 512 megabytes as limit in your Docker image, you are only going to have a heap of 128 megabytes, and the rest of that is going to be used for the virtual machines for other things or not used at all. It depends a lot of your application and how your application is consuming memory. Okay, so it can be quite inefficient. To solve that, now in Java 10 we have some parameters we can pass to the virtual machine to establish the maximum and minimum and initial RAM percentage we are going to use. Okay, this is quite advanced use, but you are running Docker in production, you have a lot of microservices running on Java, you may need to use something like this. The other thing we have is, in Java 10 also, Docker is starting to see what is the limit of the use of CPUs it can use, okay? So, by default, the thing which is doing, which is CPU charge, is I am going to use all the CPU I can, okay, or I need. But if there are other processes demanding CPU, then I'm going to limit myself to the limit in Docker. Okay, so basically that is CPU charge. Okay, it's like a soft limit where you say, okay, I can use in Docker. I know I can use half the CPUs, but because the others are available, I am also going to use it. Okay. If you need to go, need something more specific, you have also the CPUs parameter in the command line, so you can define a specific percentage of the CPUs you are going to use. Okay, basically defining the PU through the quota and the Linux scheduler, which is going to make sure in any case you are going to use more CPU and the CPU you have specified in Docker. Okay, so it's like a sub limit with CPU shards and a hard limit with CPUs. Okay. The nice thing about these commands is you can combine them. Okay, so it's not one or another one. There is also CPU set CPUs, which is basically to say to the Java virtual machine you can use only 2 or only this 3 or only this processor. Okay. It's a way to attach specific CPUs to our Java application. Okay. So you can say it's quite complex.
And those Docker parameters or virtual machine, Java virtual machine parameters?
Virtual machine parameter and in the OpenJDK, so you pass it to them to launch Java.
In my computer or there is only for Docker?
It's
Are they limited?
No, you can. It's only. It's a good question. You know, I think the memory parameter you can use it independently of Docker. Okay, it's going to limit the things. In the case of CPUs, I think it should also. Okay, because it's going to limit. It's a limit you have. It doesn't matter if you are in Docker or not. But I never tried. Okay, but I'm quite sure because yes, for sure because I ever tried. I'm doing some testing and it works well. So yes, we can do it in Docker or we say to Docker and they're working well. Good question. It's the first time. Okay. Something important is these changes are in Java 10, but most of them have been backported to Java 8. because all of you are using Java 8, right? So people from the UK have ported most of those things to Java 8. So you can already have in the last versions of Java 8 all those things too. And there are a lot of more things coming to Java for Docker. One is class data sharing, which basically is if you, for example, have a microservice architecture, this is quite possible. You have in the same virtual machines many Docker instances of your Java application, but it's basically the same Java application. With class data sharing, what you can do is to share some of the things that applications have in memory, so it's going to be more efficient, you are going to consume less memory, and it's going to help you in start time to have a shorter start time. So basically, you have your application running, you dump the thing you have in memory, and then you can use that dump in the other instances to reuse that information. Okay. More things we have is ahead of time compilation. That's something we are going to do with an example, which is instead of use the Git compiler and all that things in Java, we are going to pre-compile our Java application to a binary file, which is smaller. The start time is a lot shorter, and it's easier to distribute. It's something similar to the things the Golang guys are doing. And we have also a lot of improvements for monitoring, because when you monitor a Java application which is running in Docker, which is running in a cloud provider, it's a challenge. So there are other GKs to help us to make easier to do all the debugging, to connect a tracer and whatever you may need. Okay. We will see some examples of some of these things later with GraalVM. So I'm going to stop talking. Let's start with Docker. Okay. The first thing we are going to do is to run a Docker image. So basically, we can go to our virtual machine and run this command. And let me explain it. You are not going to see anything. So basically it's Docker, please run a Docker instance of the image Nginx. Nginx is a web server, like Apache is a proxy server. So download from internet if you don't have it. Nginx version 1.7.9. Run it in my laptop with a name. We are going to call it Docker Nginx, and open the port. In my laptop or in my virtual machines, the port 8002, and map it to the container, the port 8. Okay, so basically what we are going to do is a port which is open in the container, we are going to expose it in the host machine. Okay. So that's basically what we are running here. And Docker launch the container, launch the application, and is the application running. Okay, this is not very friendly, so I'm going just to Ctrl+C to close it, and I'm going to launch it with this value /d detach mode. So it's going to launch it in the background. Okay, so now that image is working in the background. What we can do is to test it. For example, with purge, we can do a HTTP request, and we are going to see the HTML code of Nginx. Okay, what is very interesting here is you can see how easy it is to download and run an application in your laptop. And you can do this with Nginx, with Apache, with Tomcat, with whatever application you may implement. Problems?
I would expect it you will use an entire Docker installation on the virtual machine. But apparently the image is already on my laptop, so on the host. And it's already using that.
Not exactly. Let me explain that part.
Because it's also complaining I already have a very minor name. Yes, that is right.
Yeah, that's let me. I want to explain it right now. Okay, that's me. Any problem more? That okay. Let me explain it. You can run two images with the same name. Okay. So the first image is Docker Nginx. The second one is Docker Nginx 2. If you try to run image again, the first one again, it's going to give you an error because it's going to say there is another instance with the same name, right? And you are going to say me, okay, but I canceled it before. It's not running anymore. Well, that's not true. If you do Docker PS, don't be scared, we'll explain this later. It's going to show you all the Docker images or Docker instances which are running in your lab. Okay, for example, you can see here the first one, which is Nginx. Okay, and it has been created and is ready for the last 2 minutes. If I do the same thing with Docker PS/A. You basically have two now, okay? The first one is the image I launched in the detached mode in the background, and the second one is the first, which is excited, okay? That means it's stopped, okay? So I can launch it again in any moment. For example, I can do Docker start, and this ID, and it will start the image. Probably it's going to have a problem because it's sharing the port with the other one. But what it's important here is we are not deleting it, just stop it. Okay. So remember, Docker PS to see what we are running in our computer, in our virtual machine. Docker PS A to see what is running and with this stopper. The things which are stopped are consuming not memory or CPU, but disk. So you need to clean them, okay? Is it more clear now? The problem is happening? Well, more things. You may want to see logs of your Docker instance. For that, we have the logs command. So you can do them Nginx, Docker logs F, and we use the ID. There is a cool thing in Docker. You don't need to use all the ID. Only with the first letters, it's enough. If Docker is able to identify, it's going to work. So you don't need to copy all the letters and numbers. So as you can see, I have access to the log here. If I do another pull, we'll see the log in real time, okay? Questions? Problems?
Menos A, está parado. Entonces, aunque esté parado, lo único que se ahora ves
More questions? Problems? Everybody has been able to launch the Nginx image? Yes? If it's not the case, just raise your hand. I will help you, okay? So now, we have the Nginx in the background, how to stop it, okay, with Docker
You don't have to
stop,
speed this message.
the first part of the ID, we stop it. We do our course now,
Yes.
fail.
You can see these three.
If we do a start, we start it, and it's going to work, okay? Stop it. So now with Docker ps/a, we see we have two of them stopped. As I say, we don't want to have them stopped forever, so we should remove them. Docker rm and the ID, we clean them. Okay. Proceed. If there is someone who already knows this, just try to find a command to clean your stopped containers. It's quite useful. You can find it on the internet. I can share it with you if you want. Okay, but it's basically I can launch things and then at some point and clean all of them. It's like clean the M2 folder or something like that. So just to free space in my okay, so now we know how to launch the Docker image, but we don't know what Docker image we have in our computer. Okay? For that, we have the command Docker image, which is going to give us a list with all the things we have in Nginx. It was created 41 hours ago. The size is 109 megabytes. We have a Micronaut application, and we have a lot of very strange things. Those things are Kubernetes, okay? Basically, Kubernetes runs in Docker. Okay? Sometimes some people say, what? But it's something to manage Docker instances, which is already running in Docker. Okay? So it makes it easy to deploy it, to work with it, more or less. If you want to delete, remove an image, Docker I to do it. Don't do it, please, because we are going to leave them, okay? But it's just quite simple. If you download something from internet and you don't need it anymore, just download it and use it. Okay? If you want to download an image, for example, hello world. And usually Hello World with the slash or not. And it's going to go to internet and it's going to download that application.
The first characters of the ID and those characters are the same for the two.
It's going to give you an error. No. It's going to give you an error. I am not able to identify the instance, so please use Mocha. There is a website called Docker Hub. And here you can search for wherever you want, okay, and you are going to find thousands or millions of images. If you want Tomcat, Tomcat, and you will find Tomcat, so you can download Tomcat and have it in, it's the same Consul, wherever you may need it. Okay, that's clear at this point. So you already are experts in Docker, all of you. Checkbox is done. So let's go for Kubernetes. Well, as you can see, with Docker, it's really easy to download an image of an application and run it in your laptop. Okay. But if we are going to use this in production, we are going to have more than one front. We have more than one service. Okay? And Docker alone is not designed for that. Okay, so we need to find a way to deploy an application in several servers running Docker. Okay, and see how they are going to communicate with them. How they are going to share information and things like that. Okay, and we can do that in different ways. There are people who's doing that with bash scripts, for example. It seems quite painful to me, but they are using it and they're happy. A better way, the standard way right now, is use Kubernetes. Kubernetes is an orchestrator to deploy and to manage our containers in more than one server. It's basically that. Kubernetes supports other container technologies, not only Docker. Okay, but Docker is the most popular. And in the same way, there are other orchestrators for Docker, but Kubernetes is the most popular. It's a project initially from Google, but now there are other companies very involved, like Red Hat, like IBM, like many companies. And it's of course open source. So let's start to work with Kubernetes. Basically, we are going to run get nodes. So this is a command to see if Kubernetes is running in our machine. And basically what it's telling us is, yes, it is. We have a node running, it's ready, and the role is master. Master is the administrator, and then we have different nodes in other machines. Okay? And this would be the coordinator of them. In this case, in our case, we are just running one Kubernetes instance, and it's going to be the master. We can have a lot of information with the scribe. This is going to give us logs and many information. Okay, it's a lot of it. I don't have time to explain it, but you can see here the CPU users, limits, what the application can contribute, what the resources, versions, and so on and so forth. It's a lot of information. So now it's the moment to do deployment in Kubernetes. And to do that, we are going to use a YAML file. YAML is a text format, JSON or XML. You can open it in IntelliJ or in your IDE if you want. It's in the folder Kubernetes example. And what we are going to do is create a deployment. So this is the API using YAML. Basically, we have a kind key to indicate it's a deployment. We are going to give it a name and some labels to be able to identify it. And we are going to deploy two of them. Okay, so So we are going to have two instances of this deployment. Okay. More labels to identify, and then the important thing, the image. Okay. So we are going to deploy an Nginx application as we did before, version 1.7.9, and the port where this application is going to be ready to serve is the 80 port. Okay? So we need to define in this application, in this YAML file, our application. Okay? It can be one image or it can be more than one. In some cases our application will be application server, maybe a database or any other service. So we can put together in the same deployment. That's what we in Kubernetes call a pod. We are going to deploy two of each. Okay, so let's try it. Okay. Now we can do different things. The first one is, let's see what is happening. So we're going to do that with get pods and filter with the label. So you can see now we have two Nginx deployed in Kubernetes. They are ready and they are in status running for the last 19 seconds. Okay, so we already have done our first deployment to Kubernetes. If you do a Docker PS, you will see we have two Docker containers running of Nginx. So basically, what Kubernetes is doing is just launching in the backend, in the Docker server, the Nginx. So you see, it's very clear to see the relation between Kubernetes and Docker. Okay, it's a different way to launch this Nginx service. Okay, the good thing is if we have more than one server, okay, this deployment can be one instance in this machine and the other one in a totally different machine. Okay. But in this case we have only one, so we are going to see both engine applications deployed here. If you want to see the logs and more information, again with the scribe, we can do it. And you are going to see many information about how they are consuming CPU, if they are having any problem. Yes, you deploy the application, but the pods are not up. You don't see the Docker images. You can use the scribe to see what is happening. Okay? It's, sometimes Kubernetes can be very tricky. For example, if you are running out of space in the disk, but you have space, yet, but Kubernetes can decide, okay, you may not have enough, so I'm not going to do this deployment. Okay. And maybe you have some megabytes or some gigas free, but Kubernetes is not going to do it. So you can go here to the scribe, and it's going to tell you, hey, there are this pressure, so I am not going to do this deployment because I am not sure if the full system is going to support it. So I don't do it. So you need to go to use the scribe if you are facing problems. You can see the different pods you have. And you can see also and use the name of the pod to see the logs and the other information. Okay. So you can also access to a specific logs and information in a specific pod. Okay. Is it clear at this point what we have done and how to deploy something to Kubernetes? It's very basic yet, but it's enough to understand how to put the application to work and how it's mapped to Docker images or instances in the backend. Right? Any problem? Everybody has been able? Someone? Yeah? So now we are going to do something different. Let's the case we are running 2 engine X, but now we would like to have 4 instead of 2. Okay, for that, what we are going to do is to update our YAML file. This the update version. Sorry, the scale version. Okay. Basically what we are going to do is change the number of replicas from 2 to 1, okay? And we are going to relay the comment. It's a typo here, but it's going to work. So let me do it. Right. And now the pods. As you can see, we have previously 2, now we have 1. Okay. And Kubernetes is quite clever on how to do this because it makes the change in a way the service works anyway. So there is always one running pod working. It never is going to kill both of them and then launch again. Okay, it's just doing it dynamically. It's the same thing. Let's, for example, say it's also very convenient for other things like update services. Okay? So in this case, we are going to have 2 again, but now we are going to use a newer version of Engine X. Okay, so it's exactly the same YAML file. What we are going to do is change from the 1.7.9 to the 1.15.10. Okay, we are going to apply again this configuration. Great. Updated. And now we see the pods, and as you can see now we have 2 again, and they are running with the new version. Okay? And again, Kubernetes is quite clever how to do it. So basically, it starts the new pods with the new version, and once they are ready, it kills the others. Okay, so it makes sure the service is available all the time. So it allows us to upgrade our applications without loss of service, without service loss. Okay, we have seen how to scale. Finally, if we want to delay our deployment, instead of apply, we can do a delay. There are no pods running. Well, that's the last part about Kubernetes is, okay, we are launching services, we are launching the Nginx, and we are accessing to it from our virtual machine, okay? But how to expose that service to internet, to other servers or consumers out of Kubernetes, okay? And to do that, you will use a service. Okay? Service is basically tell Kubernetes how to expose the services, the services you have in your pods. So let me show you one of them. But basically, we are going to launch Nginx again. There is a shortcut to launch it. When it's something very simple, you don't need a YAML file. So you can do something like this. And it's going to use all the parameters by default, and it's going to work. That works well for very simple things, but that's not very normal. Most of the time, you need to work with the YAML files. Launch it. And now let's create the service. So basically what we are going to map is in our Kubernetes host, we are going to map the port 80 to whatever pod is running and providing a service in the 80 port. Okay? This now we see if it's working. Service. Okay, and as you can see, what it's going to tell us is, okay, you have an Nginx service, the type no port, orchestrator. It has an internal cluster IP, internal Kubernetes IP, and it's mapped the port 80 internally to the port 30,180 or whatever you have in your computer in the host. So if we do a full local host ports, and local host, you need the IP of the machine. You are going to see the website of the web page of the Nginx server. Okay. Node port is not the only type of service you can create in Kubernetes, and indeed it's not very popular. It's easy to use it, but it's not very popular. Most of the time, the people is using other type of services like load balancer. So you are doing all the load balancing to your pods, which is typically provided by the cloud provider. So you are going to create a load balancer service in Google Cloud, and basically Google Cloud is going to use their own infrastructure for routing and so on. Okay, so to open the ports of the application you are running in Kubernetes. Okay? That's the normal thing to open ports, not with node port. But this one is quite good for a workshop to show it and to see how to work with it. There is another one which is using a DNS server internally in Kubernetes. So basically it's going to map your services to different host names and URLs, and it's going to give you so you can use them to invoke the service. And also it's working. It's a better way to work with. Okay. For us in this workshop, it's a bit more complex, and it doesn't have too much value. But if you want to expose services in production and want to do things more serious, you need to use some of the machines. finally, what we are going to do is delete the service and the deployment. And deploy. So now connection reviews. How many of you have been able to launch and invoke the JX server in Kubernetes? Raise your hand. How many of you? Okay, so the rest of you are working on it, right? Any problem or any help you may need? Is it working well?
No, I was on someone
Any problem? So, would you like to do a break, 5 minutes, or do we continue with the workshop? What do you prefer? Are you tired or not? 5 minutes break? Okay, so let's do a short break, it's 5 minutes, drink some water with the lunch, and we're going to continue with the Micronaut part, okay? If you have any question, I'm going to be here, so let's continue. That's a bit much, or? No, it's good. Let's just try it. The USBs, would you recommend them? Thank you. Is everything working well? You have any questions?
Yes, I don't know. I think
Spanish you prefer.